All right, so we're back for part two. We're going to go ahead and check each injector, make sure they're not bleeding down, if that's what's causing a rich condition. I'm not saying it is or is not. Well, we got our fuel gauge hooked up in series there in line. Then I got my pulse mode tool hooked up. And then I got positive, negative going right to injector one. I got the pigtail harness unplugged. Let's show you the light here. I got the wires on the harness unplugged from each injector. I'm just giving a positive, negative to the injector. Go ahead and hook up my tool here. So there's 4 modes. I'm going to go to mode 2. That pulses it for 50 milliseconds. What I'm going to do first is I'm going to cycle the ignition to get full fuel pressure. I could find the fuel pump relay or fuse and power it up that way too. I'm going to go ahead and cycle the ignition. Alright, got key on, engine off. We're at, you want to take note, 42, 46, 48 PSI. 48 PSI. I'm going to cycle this. I'm going to push pulse here. And I'm going to watch this. You're going to listen and watch it drop. So it went to 40 PSI. So it dropped. Went to 40. I cycled it there. So watch this. I'm just going to show you again. I'm pushing this button. And it pulses it down. And it went down. So I don't care about the second time, but the first time it went from 48 to 40. We want to write that number down, compare all these, and you want to be within a half a PSI of each other. After you're done, you want to crank it over, start it, get all those gases out of there. You don't want to do this more than once per engine cycle. Otherwise, you'll fill up your cylinders with a bunch of raw fuel. All right, so I recycled the key. We're back at 48. Cylinder 2 now. I'm going to hit pulse. Here we go. Got to stop moving your hand. Perfect. A little bit under 40. Yeah, we're right at 40. Same as before. So cylinder 1 and 2 are within each other. So now we're going to do 3 and then 4. Alrighty. So let's set up the tool again here. Mode 2. And we're at 48. Don't move. Here we go. Cylinder 3. We're good. 40. Now we're going to do cylinder 4. Cylinder 4. Hold the gauge still. We're at 48. Don't move. We're going to pulse it. 40 PSI. So we're good there. Alrighty, we're back doing some more oxygen sensor testing. I got my oscilloscope negatively hooked up to battery negative, and I got the positive hooked up to the signal wire. Positive to the signal wire of the oxygen sensor. Car's running. Still got misfires. So now I'm using the oscilloscope, looking at it. The reason is because when you look at the scan tool data right here, this is actually processed data, right? It takes time to process it through the oscilloscope, but if I go to the, or not the oscilloscope, through the scan tool, so let me do that again. Process data through the scan tool. This is immediate because I'm right off of the signal wire. So the center line, okay, actually 0 volts, 1 volt. The center line is 450 millivolts. Anything below that is lean. Anything above it is rich. So right now it's running rich. It's rich the whole time. That's what the computer's chirping it as. That's why the field trims over here are extremely negative. Look at 25% negative, 27. So now look, it's within the cross counts again. So we're good there. Then it's rich again. Rich, 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 rich. Above that center line, above 450 millivolts. Still rich. And then eventually it'll cross down into that, and then it runs better. Right there. Now it's running better. I can hear it, the audible tone difference. It's running better there. And it takes time. The O2 sensor does its stuff, process it, change the field trim. See there it's changing. So the O2 sensor picks it up, makes a request to go lean or rich, adjusts the field trim, and back and forth. That's how it adjusts it. So when it says, okay, it's running rich, if it's running rich off the O2 sensor, it'll say, okay, pull the field trim back. If it's running lean, it'll add field trim. You know, this going to that based on that. Well, I just wanted to look at that data on the oscilloscope itself. They were running rich. So what's it going to do? It's going to take and try to adjust the field trim and pull it away. So it's increasing right there because it's a process. And then it's going to say, okay, that's too rich. So then it's going to go back lean. It's going to go down there. And it's going to go the opposite way. There it went opposite. Now we've got both cross counts. So I'm trying to figure out why this thing is running rich there. And that's what's causing our misfires to do that. The other thing I looked at is the mode 6 data. Because maybe the cross counts, you know, for the sine wave lean and rich wasn't enough. But if you look, lean to rich switch time, lean to rich switch time for both sensors, for the hexadecimal numbers there, they're both within the specifications. They're okay. So we got to figure out why this thing is running rich and compensating. And then our field pressure as it's running is 44 psi. If I rev that up, it goes up to the 50. There we are, 44. So that's all good within specifications. But we're going to have to do some more checks and figure out why this thing's running rich only at idle. As soon as you hit the gas, misfires go away. For example, this light will flash in here when it's misfiring bad. You touch the gas, bring it up above the idle stage, the misfires go away. The light stops flashing. Then there's just some history codes. And it only misfires at idle. So another check here is we're going to look at the map sensor. Let me go ahead and turn the car off. I got key on, engine off. And if you look, I'm going to refresh this data. Because I lost common when I turned the key off. Go to live data. We find it here. Map sensor. Barrel. And then I want fuel injector. So we're at 3,000 feet here in Mountain Home, Idaho. So the map sensor should be around, 13.1, 13.2 PSI. So that's where we're at. So I'm gonna go ahead and start the car now. So now we got it running again. The barrel pressure is obviously the same because that's where we're at, 3,000 feet on Earth. Map sensor is reading 4.2 because there's a vacuum on the engine obviously when it's running. Now the fuel injector milliseconds, you can see those there. I see that. Just graph this. So 2.8, 2.9. Just gonna let it run a while and watch it. See how much it really changes because obviously if it's running lean or rich, it's going to adjust the milliseconds opening or how long the injector's opening for in milliseconds. Seems pretty stable there. It went up a little bit there. You can see it spike there. There's some other data I wanted to show you. So another data I wanted to show you. I just turned the car off. It's at 48 psi. If I let this thing sit for, 30 minutes, an hour, it only drops to like 40, 42 psi max that I've seen in the last 30 minutes to an hour. So obviously we have nothing bleeding down, and we proved that earlier with the actual injector bleed down test. So we're going to continue to troubleshoot and see where our rich condition is coming. And like I said, it's only at idle. All right, so we went ahead and replaced the L2 sensor. We got significant different results, and I'll show you here. So right now we're in closed loop. Still got a higher field trim, or a negative field trim. No negative 20 some percent, and I cleared out all the data, you know, or all the codes. So we're still negative 15, 16, but not a negative 25 or 27%. Well, if you look at our O2 per the scan tool, 0 to 1 volt. So anything below it's lean, anything above it's rich. But look at the cross counts at idle. Significantly better. That's just that idle. Look at that. I mean, it's going all the way up and down. Can you rev it up? Just rev it and hold it a little bit. Like hold it though, like you mean it. Okay, let off. So that's revved it up a little bit. But the cross count's significantly better. Field trim's still it's still pretty negative, right? 19%, 18%. If you go to the oscilloscope, which we have hooked up on the signal wire, you hit start. And now it's above it. A little bit ago, there we go. Now it's got a wider sweep now. The fan was on there. I don't know if that would affect anything. I wouldn't doubt it. Maybe a load on the system. But right there, we're back at idle. We're just idling. So if you remember before, below this cursor line is lean, above it's rich. Well, right now we're kind of on the lean side, but on the rich side a little bit, so our cross counts are good there. Remember before it would stay high up here. But it's not. It's like, it's perfect right there. Same thing with our O2 sensor readings. There's a lot more cross counts. And if you go back to the O scope, it's good there. Go ahead and rev it up, like a little more. Alright, so then you see your cross counts are really good there. Let it catch back up. Significantly different. It's not stuck on the high side, meaning rich, like it was with the old O2 sensor. We got the new one in, and everything looks good on the O-scope side and the scan tool side. I mean, there's your halfway mark. Looks awesome. Now, but your field trim's a little still negative. But here's what's the issue. Not another issue, same kind of issue. We have a pending code, which is the 1399. Pending 1399, which means it's a random misfire. And I cleared all the stuff out, and our engine light's back on. So it was misfiring, but last time, if we were to run it for, and we've been running for 10-15 minutes, within the first couple minutes it would say cylinder 1, cylinder 2, misfiring. It hasn't done none of that. It's got a pending that it's a random cylinder misfire. Let's go ahead and look at the Honda specific data and look at that and go from there. So now I'm in the Honda program. I got a P1399 misfire in any cylinder, meaning it's a random misfire. Before it said it was cylinder 1, 2, and 4, but right now it doesn't have a hard code. It's temporary. Before it was a permanent fault. It had a P0301, a P0302, a P0304 for cylinder 1, 3, and 4, or 1, 2, and 4. But right now it is significantly better. So I'm going to clear these faults out again and continue to watch it, because that O2 sensor reading is like a night and day difference compared to the old one. This is at idle. I mean, that right there looks okay. It went high there, a little rich there, a little rich there. It was going rich, but it's a lot more. It's not as rich and as long in duration as it was before, and the amplitude is covering more area. So what I want to do now is I want to look at the mode 6 data again and go from there. Disregard the mode 6 data. I'm going to clear these codes and then rerun it and then see what we come up with. Cleared, no fault codes. Now we're going to restart it. So cleared it, reran it, recycled the key. We're running again. No fault codes. Go and look at the oscilloscope reading. So we're on rich there. Now we're good again. Cross counts are good. I'm assuming it's in closed loop. We'll take a look. We'll look over here at live data. Make sure we're in closed loop. I don't know why this thing is not focusing again. Closed loop. Field trim is still negative. Pretty negative. No codes yet. So I'll look at something else. So much better. It's not above this line like it was before with the old O2 sensor. Cross counts look so much better. And we're not as negative. Back to the oscilloscope. Oscilloscope looks awesome. There's some focuses. That's a night and day difference. I'm going to go ahead and read codes again and see. Reading codes again. See where we're at. Boom. Pending. $13.99. This will be pending. So that's the random misfire. But the O2 sensor obviously needs to be replaced. It's significantly better. We're not throwing a hard code. We're not throwing a cylinder 1, 2, or 4 misfire. The engine light's not on yet because it's pending. But we're still having a pending misfire code, so we got to figure out why and go from there. All right, so we've been running a while. It's at idle. The electric fan's not on right now. No load on the engine, and that cross counts off the oscilloscope is perfect. I mean, obviously the O2 sensor needed to be replaced, but don't mind that popping. That was just a stove over there, wood burning stove. But this is perfect right now. Except we have that pending code, but like I said, we don't get a hard code. We don't get a specific cylinder. And it's running a much better, but we still have a misfire that the computer's picking up from something. Alright, so it's good there. Go ahead and unlock the doors. You can hear the engine change. Unlock it and hold it up. You can hear the engine change. Lock it. Unlock it. You can hear the engine change, okay? Now let's watch the scope. Don't do nothing yet. Looks perfect. Unlock it and hold it. Rich. Let go. You let go. Let's let it equalize out. It's good. Unlock it. Don't hold it. Just unlock it. You can hear it change and go. Why is that changing? Well, there is a load on the engine, right, and load on the alternator. Just something we noted. So maybe we have to go down that road as well to troubleshoot this vehicle. All right, so I'm back in the Honda program. We still got the $13.99 misfire in any cylinder. Now, nothing specific like it was. It smoothed out significantly. But what I want to do now is I'm going to pull up the live data. I'm not saying this is an issue, but what I want to look at, because we put an electrical load on the circuit, you know, lights, door locks, it does surge the engine, which maybe is expected because the alternator's got to keep up, and it's going to adjust accordingly, right, for the demand it's putting on it. You know, more amperage, right? It's going to work the engine harder because the alternator may go to full field effect or such. But what I'm going to look at now is the so right now sensor 1 heater for the O2 sensor is on. I have my oscilloscope hooked up to battery ground, the other lead to the ground off the actual O2 heater. the computer, the PGM FI on this is the ECM or PCM, controls the ground. And it says it's on. And it's not duty cycle or pulse width modulated. But if I go to my oscilloscope and I hit start, I got 200 millivolts of voltage, 0.2. Well, I should have no more than like 50 millivolts. I would think this would be at 0. And the computer grounds this, and then the computer gets grounded. So I think I'm going to look at the computer grounds next, perhaps. That, maybe some AC ripple, and go from there. It just seems like, to me, this would be closer to 0. Yeah, average is 200 millivolts. But I would think that should be, you know, pretty much 0, right? So if I move this ground, or this clip to, like, say, chassis ground, right there, which obviously it's from the battery to there, I mean, I got 0, right? Nothing. If I go back to that, I got 200 millivolts again. Typically, you don't want no more than 50 millivolts. We got 200. So, maybe, I mean, obviously this goes back to the computer. I'll check the computer grounds and then go from there. So then if I take and jump that ground for the heater to the battery ground while reading with the oscilloscope, it's a lot closer. I got 25, 26 millivolts, under the 50. Problem with that is when you do that, it says the O2 sensor heater is off. And what it does then, it'll throw a separate fault code, O2 sensor heater failure, permanent DTC. And if you go to live data, it's going to probably be an open loop. So maybe the computer knows there's supposed to be 200 millivolts. Yeah, it says, I just saw it, open loop diagnostic trouble code. So it reverts back to that. So maybe the PCM knows that there's supposed to be some millivolt backfeed, but something I still want to check out and go from there. Alright, I just wanted to check AC ripple. I don't think it's a problem, but oscilloscope, battery negative, negative lead, positive lead to the back of the alternator. And I am within specs. I think, if I remember correctly, it's no more than plus or minus 300 millivolts. Or maybe it's more than plus or minus 3 to 500 millivolts would be considered bad. I'm just looking at the center humps rate there. And I only got like 47, 48, 50 millivolts. So our AC ripple's good. We don't have lights flickering anyway, so maybe so that at least eliminates that from the equation. What we're going to do now is check some computer grounds, main grounds, make sure all that stuff's good, take it for a test drive, and then go from there. So another thing we want to look at, you know, with all this rich condition, there might be excessive fuel in the oil, right? So if you have excessive fuel in the oil, it'll cause rich conditions too. So we're going to go ahead and do an oil change on this. Maybe looking back, there was, you know, obviously misfires. The O2 sensor made a significant difference, the new one. You can see that on the scan data on the oscilloscope. And the fuel trims are better, but they're still negative. But I've seen also where you have all that raw fuel sitting in the oil and it picks it up from the fumes. So we're going to go ahead and do an oil change. And then it needs one done anyways. And then we'll go from there.